Okay, good morning, everybody. I hope you guys are doing well. Uh, I hopefully you understood the first lecture on Chapter 8, Section 1. I think it was fairly straightforward. Remember, anytime you have any questions, feel free to email me, or you can also put a private comment on Google Classroom. Either way, I will respond back. I do check email more frequently. So that'll probably get me to respond a little quicker, but either way is perfectly fine. So today we're gonna talk about adding polynomials. So this kind of goes along with what we did the last time I posted a lecture, in that what they like you to do first when you add polynomials is to make sure the polynomial expressions are in standard form, and the reason why we do that is then we are grouping all of the like terms together. So looking at this first example problem in your notes that was already done for you, you can see that we have 2x squared plus 5x minus 7 grouped together. And then it says plus 3 minus 4x squared plus 6x. Now, the first thing to notice is, where are our like terms? We have a 2x squared right there. We have a negative 4x squared. Then if you look at the next like terms, we have a 5x right here, and we have a 6x right there. The last like terms that we have are going to be the minus 7 and the positive 3. So by color coding those like terms, it makes them very easy to see. And what you'll see in this first line right there, after the original problem right above it, is they actually took brackets and they grouped all of the like terms together. So you can see the x squared terms are here, the x terms are here, and then the constants are here. And by doing that, it makes it very easy to see which ones we need to add up, which ones add to each other, if you will. So I am color coding all of these so it makes sense. There you go. And then the last thing they do is add up. You can see the 2x squared plus negative 4 ends up being negative 2x squared right there. And then you have under the purple the 5x plus 6x, and that ends up being 11x. And then you have the negative 7 plus 3, which ends up being negative 4 under the light blue. So hopefully that made sense, and I didn't go too quickly through it, but let's do a couple problems on our own. All right, so we want to add these polynomials up. Now, I'm probably, for the first couple, I'm going to reorder them. If you don't think you need to reorder them and you can just recognize which ones are like terms, that's perfectly fine to do. I'm going to color code these to make this as user-friendly as possible. So you can see right here we have a 5x squared, and then we have a negative 3x squared. So those are all underlined with blue. Now I'm going to go to red, and we're going to underline the next set of like terms. So I have a negative 3x here, and I have a 6x right there. Now, I guess I should actually, let me do one more thing. Here's the purple, and we have a positive 4 here and the minus 3 here. So before I go to add those up, I guess I should ask, do you understand what makes things like terms? Ask yourself that in your head. If the answer is yes, that's great. If the answer is no, then we probably need to stop and discuss what that is. Here's what makes things a like term. They have to have the exact same variables, and they have to have the exact same powers on the variables. So if you look at the ones that are underlined with blue, you can see they both have an x. But what is also needs to be true is, not only do they have an x, but it's an x squared. Now, if you look at the ones that are underlined with red, those are x's, but there's no square on them. They're both only x to the first power. That's what makes those like terms. And then the ones with the purples are just constants. So now we can rewrite this if you want. You don't have to rewrite it if you don't want to. I'm just doing it, like I said, to make this as easy to follow along. But we can write 5x squared. Then we can write plus 6x. Then we can write minus 3x plus 6x. Oops, I goofed up. I apologize. Let me back this up. It's 5x squared minus 3x squared. That probably makes more sense. Then we have minus 3x, and then plus 6x, and then we have plus 4, and then minus 3. Now, if I go and I underline, you can see what I did with these. The first terms, there's your blue terms, followed by your red terms, and then followed by your purple terms right there. Now from there, everything that is underlined by color gets combined. So 5x squared minus 3x squared is 2x squared. Negative 3x plus 6x is positive 3x. And then 4 minus 3 is 1. And that is the combined polynomial in standard form. All right, let's do another one. So once again, I'm going to color code underline these because I think it makes it easy to understand what's going on. Let's go with our highest power. So I have a y to the fourth right there, and I have another y to the fourth right there. Next one we're going to look for is y to the third. I see a y to the third right here, but there is no y to the third in the first group, and that's okay. There doesn't have to be, but that 2y to the third that I underlined is going to be kind of its own thing then. Now we're going to go to y to the second. And if you look in the first grouping, this whole grouping right there, there's no y to the second. If you look over there, there's no y to the second. That's fine. So now we want to go to y to the first. And there's a y to the first here, and there's a y to the first here. And then the last one that you want to take a look at is the constant term, which there's a constant and there's a constant. So now we're going to go back. Let's rewrite this so we have all of our like terms together. So we have a y to the fourth, followed by a minus 2y to the fourth. So that took care of the purple terms. Then we got to go to the red one right there, which is a plus 2y to the third. Cross that off. I like to cross off the terms as we use them so we don't forget to write anything down. Then we have a minus 3y, and then we have a plus 2y, and then we have a plus 7 and minus 11. All right, so we have all of our like terms together. There's that one. There is our single y to the third. Then we had our y's, and then we had our constants right there. You can see now they're all grouped together. And finally, we are going to simplify them by adding and subtracting the like terms. So this is 1y to the fourth minus 2y to the fourth is negative 1y to the fourth. Now the red one doesn't have anything else to combine it with, so you just rewrite it, 2y to the third. Now we have negative 3y plus 2y, which is negative 1y. And then we have 7 minus 11, which is negative 4. All right, guys. I think that is going to be it for this one. Yes, it is. I will go into subtracting polynomials in the next lecture. Have a great day.